Hello, so it's Mesomachi here, and together with a fellow instructor at Special Maths Academy, Pius, we will be discussing the solutions to the just concluded 2024 Special Maths Contest, the first round. Please share this video, like, comment, and don't forget to subscribe. We need those subscribers. Enjoy the video.
So, good day, Mr. Pius. What do we have here? So actually, we want to start discussing the problems from the just concluded special maths contest, and we'll be starting with
Right.
problem 21. Okay.
Very good. Hello, Ms. Machi.
Hello.
So let's look at this problem 21. So this is under algebra, where basically we just need to perform some substitution and then try to simplify. So first, there are different ways we can go about this problem, right? So a more straightforward approach would be just to substitute. So we have here x, y, and z in terms of a, b, c, and then in a similar way, u, v, w in terms of x, y, z. So we can substitute the expressions for x, y, and z to find out the relationship between u, v, w, and the initial ABC also, right? So that way, everything will be in terms of ABC, and then maybe we can confirm from the options. So that would be a more straightforward way, which we'll take a look at that first. Then can check also maybe faster ways we can go about this.
So,
do you have any questions in particular? Yeah.
Just to cut in, I mean, as a student, looking at this question, and the first thing I'll just observe is that all the denominators are the same, and I don't know, I'll just try and add everything. Right. But thinking about the special maths contest and seeing that this is like 21 out of 25, and problems are supposedly arranged in order of difficulty, I would think that maybe that's, I don't know, that might feel like I'm heading down a wrong path. Do you think a student who starts on this path can recover something quickly? What do you think?
Actually, I think this is very important because, in fact, I would say it's a good approach regardless. Because, for example, here we have in the denominator the sum, right? So we have the sum. So the sum certainly is going to play some role. So it's not wasted if you start from there. In fact, we would actually need to compute the sum if we're going to simplify this.
I see.
Yeah. So maybe we should even start with that. Let's begin with that.
Okay. I mean, just looking at this problem, I feel intimidated because I think I can count 9 variables here. This is why I don't like algebra.
Yeah, but also for Olympiad, sometimes you can expect that there's something interesting going on, right? So it's for you to discover what is that. That's something special.
Okay.
So sometimes if you're not sure, you can just start with what you know, and then with time, maybe you'll be able to see more things as you begin. So first, let's just get the sum.
Okay.
So we have the same. Sorry, let me reposition mine. Okay. So we have the same LCM, like the same denominator. So the LCM is just a plus b plus c. So here we just have to add the numerators. Now I'm going to write it in this form, just for symmetry. Okay. So we have this. Now, probably at this point, one may be able to recognize that there may be some identities that may be able to come into play in terms of simplifying these things. So hopefully we can be able to factorize whatever appears. Yeah.
Anytime I see, this sum like a squared plus b squared plus c squared minus ab minus bc minus ca. So there are two things that come to my mind. So in this scenario, we have that a, b, b, c, and c, like they have a negative sign. They have a different sign from the a squared plus b squared plus c squared. So I think the first thing that comes to my mind here is a minus b all squared plus b minus c all squared plus c minus a all squared. Then all this divided by 2. Yeah. But then if the sum was positive, if a, b, b, c, and c had a positive sign, what would come to my mind would be two things. So either I'll find a way to like try to relate it to a plus b plus c all squared, or I'll then do a plus b all squared plus, bracket b plus c squared plus bracket c plus a squared. But yeah,
Right.
do you think that can
So
help?
actually, this is interesting. So this usually, if you have questions involving like sum of squares, this is usually a very very good way to start. And the three elements in this within the squares, if you sum them, they actually add to 0. So that's
Yeah.
something to note. But in terms of factorization, actually another one that should come to mind is this identity.
Yeah. I remember this identity.
This identity, right? So it has
a
like
very,
this
very
beautiful
annoying
factorization. Actually, I love
But yeah,
it.
this takes me back to my days in university. So we took a course in algebra, and in algebra we discussed something called symmetric polynomials. So symmetric polynomials are like just like what you've written here: a cube plus c cube plus, like a cube plus b cube plus c cube minus 3abc, right?
Yeah.
And I think one interesting thing about symmetric polynomials is that I think by definition, why they're symmetric is if you swap the positions of like A, B, or C, like no matter how you swap the positions, you always get the same polynomial at the end of the day. That's why it's symmetric.
Yeah.
So one thing about symmetric polynomials because is that you can always express them in the sum of some specific group of polynomials. So for instance, now we have a cube plus b cube plus c cube minus 3abc. So this can be expressed using a linear combination of the sums a plus b plus c.
So you have
yeah.
Yeah, let me write that here. So you can write in terms of this. This is on one hand.
Yeah, exactly. So like the Vieta's expression, something like that. Yeah.
Exactly. This is on one hand. On the other hand, you can also consider it in terms of sum of powers. Usually, this is a more fundamental way, I think, of breaking them down. So you could usually I just call this S as in sum. I call this P as in product, and then this I can just give some random stuff, maybe T.
I mean, it was a very interesting thing because I think at some point I was working on trying to see if there's just like a systematic way of trying to like find out if these symmetric polynomials have some factorization, but that's just by the way. That's a tangent. So let's continue with the problem though. Yeah. But yeah, this is a very, very interesting factorization.
Yeah. So actually, sometimes in terms of factorization, you can look at a degree to help you. If it's symmetric, then if it can be factorized, there are only few options in terms of degree. And the factors will also be symmetric, right? So in this case, if you're going to factorize this, at least you need the linear factor, definitely. So that can only be a plus b plus c. Now it's left for you to figure out if there's actually something on the other hand that can actually match up with that.
And I think back in my days in secondary school, nothing I was trying to explore in like give me a hint of how to factorize these things in exam, or to like consider substituting integers into those polynomials, right? So for instance, if you consider this, a cube plus b cube plus c cube minus 3abc mode 3, I think mode 3, and some other specific modes. I think that's where you can prove that a plus b plus c would always divide that symmetric polynomial. But it's a long time ago I tried to explore something like this with this specific polynomial because I think I saw it in, I think there was a book of Tito and Driscoll I was reading, and I think that was the first place I saw this factorization, and it's really interesting.
Yeah, factorization is really interesting. Like for example, if you suspect that a plus b plus c is a factor, if you want to confirm this without actually factorizing, you can try to make this like mode a plus b plus c, where this is like 0, so that c will become like minus a minus b sort of thing.
And then substitute it,
When you plug that in, if you don't get like 0 completely, then you have an issue. It's not really a factor.
Not a factor. Yeah. This is this is the better way to go about it. Yeah. So it's kind of like
easy to check for this
case. Like factorization theorem, like polynomial factorization theorem, Bezi's theorem, something like that.
Yeah, basically. So it's usually good if the degree is not too high. If it gets high,
if it gets too high, it's not fun again factorizing. But yeah, let's continue.
Okay, let's continue. So now we have the denominator for each of the U, V, W at least in terms of ABC. Now let's get the numerator. So like we mentioned before, this is symmetric, right? So
Yeah.
if we can figure out for one of them, we could probably write the expressions for the others just by changing the focus. So here it's like focused on A, this is like on B, here C is like the special case. So if this is now focused on X, which will now kind of relate back to A in a very special way. And then this one will relate back to B and so on. So if we can express U properly, I think we can have like the others also. So let's start with U at least. And the question also has like U involved. So definitely we want to start with U.
Yeah.
All right. Now the denominator, this is
Why?
quadratic.
Sorry. Why would we exactly
Yeah.
want to start with you?
No, because the options, for example, like most
Okay.
of them have like
Have
U
you in
as like
them?
yes. Only
Yeah, I see.
the third one where we may need to consider like the sum.
Yeah, I see. Okay. Yeah.
Yeah. So let's start with U. And from the options, maybe you shouldn't be too complicated, hopefully.
Yeah, hopefully.
Yeah. All right. So here they are quadratic. So let me just write what we have first. So the denominator would also be the same for both sides again. Excuse me. B, C. Okay. All right. So here we can see that A plus B plus C would appear in the denominator as square in both cases. So we can take this as the LCM. So what we are left with here is this squared minus this. So just need to focus now on the numerator. Now this numerator, our hope is that it's something factorizable, right? But
We
it's
hope
going to
so.
be degree 4. We hope. This is
Yeah.
degree 4, so let's hope. If it's not, then we'll try to see what we can do. So here, now expanding on the first part, so I'll just go ahead and expand. So this is for the first bracket, minus, now for the second one, we have b squared, c squared, ab cube, ac cube. So at this level of this question, we expect that this should be basic stuff, right? Yeah. Okay, so now we need to just open this up just to make sure things are clear. Let me just open it before we make any cancellations.
Yeah.
But in terms of exam condition, you might want to be a bit more flexible
Faster.
with how you go about these things. So this cancels out, and there's an obvious factor, right? So at least now the degree is will be more friendly, I think.
So what's the obvious factor?
So can you see an obvious factor? So I would like to so these two add together to make 3. So I'll just write this like this and change this to 3. It's an obvious factor. Can you see it? Maybe it's too obvious.
Nah. I
Okay.
mean, I
If I
can
write
see
it,
that
I'm sure you're gonna see it.
A is in each of them, so we can
Yeah,
quickly like.
that's the factor. I mean,
Oh, that's a
maybe it's
factor.
too
Even
obvious.
I
You
was
see,
already going. My mind was going very far.
yeah, it's too obvious. Can you see it? So
Yeah, and then this points back to that expression that we spoke about earlier on.
yeah. So at this point, if we didn't know, then we'll have to work on this to consider at least if there's like but even without doing that, right? Definitely this is symmetric.
Yeah.
It's already good news because this means if you try to write for the V and W, it shouldn't be too complicated at the very least.
Yeah.
So yeah. So let's before we even factorize this, let's just put things together for U. So U would be x squared minus this over x plus y plus z. So it will be this divided by, just to make sure we are on the same page, over a plus b plus c. So this is what we're dividing here. So one of the a plus b plus c will cancel out. So we now have at the numerator
So can you just put that this is equal to x plus y plus z, like this stuff of dividing by, maybe just put an equals to or a bracket at the right corner so that the audience can follow.
Yeah, so okay. You mean here?
Yeah, just and box it in the green or something. Okay.
So this
Yeah.
is this here is x plus y plus z. Okay. And here is coming down. This is x squared minus y z. So we're just dividing these two. So I'm skipping a bit of step here with an assumption. So in case
the rest of the solution is left as an exercise to the viewer.
exactly. Yeah, so you get this. So either way, if you're already familiar with the factorization before or not, at this stage, there are a lot of things that could happen, right? So yeah, either way, the hope is for you to just simply get A. At this point, you should just get A.
Yeah.
So if you have this, the rest becomes straightforward. Actually, we already have our answer, right?
Yeah. So maybe we can just scroll back up so that we can see the options again. Okay. So here we have U equals to A. So let's see what the options were again.
Yeah. So we have option D. So let's look at the options. So the first option, if U is A, this will become, let me change this to maybe green. So for the first option, if U is equal to A, this will become A squared to B. This doesn't follow immediately. Like it's not natural. So this is not an identity. It doesn't work. The next one also similar issue, right? If U is also A, then you have 2A and then 2X. X is not directly A, so this doesn't quite work. For the third one, now if U is A, right, then based on what we said before, it will make sense for by the symmetry for V to be B and W will be C.
Yeah.
And that will give us this sum, which you already computed. So this will have to be equal with this sum here. But it's not identity, so it doesn't quite follow also. And then, of course, we just got this. The last option will be U is now A, so it's X equal to A. The same issue with the first two. So that would be just from direct computation. But you have to be able to handle your factorization properly, especially that final step. Otherwise, if you have like very huge polynomials and you start adding and trying to do squaring, it's not going to come out so well. So you do need to simplify. So now it's a slightly more elegant way to go about.
I'm really interested in that.
Just slightly more elegant. Okay, so let's.
Can you? I don't know if it's possible to like copy the
picture,
question.
Right?
Yeah, the picture down here.
Just a moment.
Not all of us have, photographic memory.
Oh yeah, so that is also one thing I think is very. Give me a moment. So that's also something that's.
Yeah, I think control copy should.
This one. Yeah, I think this should be okay. This should be okay, I think. This happened. Okay. Just need to move this.
So you have to move it down, yeah.
I hope it's not taking the entire thing. Hold on. Nah. let me recopy from the source. Give me a moment.
Okay. Yeah. So this is an interesting question.
So, so what do you think about the outlook of the problem? Like, does it look intimidating, or Like
I
what
would say it looks intimidating, if I'm being honest.
as
Yeah,
compared to
because
the solution? How
of
would
the
you
solution,
contrast
as
the
compared
two?
to solution.
Mm.
I mean, under exam condition, maybe because of time, I would say it's having to deal with lots of, algebraic factorization, not something that maybe a student will want to deal with
At
under
this
exam
moment.
conditions with time. But yeah,
Yeah.
with the solution, I would say it doesn't look that complicated again. But that's the thing with most math problems. When you solve them, then they don't look as difficult as they were before you solve them. So
Right.
it's not
Yeah.
it's not
So it's a different story after
yeah
you've seen the
yeah
solution.
it's not a good way to judge. It's better to judge a problem before you solve it, because after you solved it, then it's, I don't know. I feel the judgment becomes biased. But yeah, or
Okay.
after you've solved it or you've seen the solution. So it depends on the case.
Yeah.
So yeah,
So
just looking at this question and
hmm,
seeing some, like basically the expressions are homogeneous, right? So for instance, x is expressed in
yeah.
um in terms of A, B, and C, and in a way, you can say maybe it's, if we give A, B, and C some degree of freedom,
Yeah.
how does that relate to the degree of freedom of X? I don't know if that question makes any
Yes.
sense to you.
Yeah, I know what you're trying to say. So that's a good perspective. Unfortunately for this problem, it doesn't help. Okay. Um, so here, if let's say we attach some kind of degree to let's say we call it n or something, then the degree of the numerator would be a times a, so that would be like 2n.
Mm-hmm.
And the degree of this, if they all have the same degree, so we're assuming they all have the same degree, right?
Yeah.
Important. Okay. So this will just be n. If we divide, you just subtract the degree to give n again. So x, y, z will also have degree n, u, v, w also have degree n, and that is factored into
Yeah.
the
So we
options.
we,
So
we,
they
we can't
all
use that to
balance in
eliminate
that
any
sense.
option.
Yeah. Yeah,
I
unfortunately.
see.
Yeah. So something else that one may be able to try though is to fix specific values for A, B, and C, but
Mm-hmm.
try to make sure they are not make them more generic, like
Yeah. So
random,
don't
let's
make
say,
them
more
trivial.
random, not too trivial, not too connected, not too special, but also not too big. So it may be tricky to find the appropriate one, but one can just try something and then probably most likely most of the options will be eliminated at the very least. Then you can try another example and then probably that will finalize it, right? So that will
So
be not really solving it directly, but just based on option. So for example, maybe we can even try some before I show the other stuff. So we can just pick values for A, B, and C. This will determine X, Y, Z, which will now determine U, V, W, right? The only issue this might have is when we have fractions, right? So it depends on how ready you are to work with fractions.
So it depends. You pick your poison. Do you want to work with factorizations, or you want to work
Yeah,
with just expression simplification, like lots of fractions and things like that?
yeah. So you may want to choose your values a bit wisely. So maybe you can just pick C to be 0, right? I mean,
Uh-huh.
there's no reason why not. So if we do that, X will become A squared over A plus B. Maybe this will guide us a bit to make the fractions not too heavy.
Yeah.
And also we'll avoid the denominators being 0,
Yeah.
definitely. Yeah, so from this, if A and B are like coprime, then most likely this will not work except the denominator is like 1. So we may want maybe A plus B to be precisely 1.
So what
So you
does it
can
mean
just
for
say
two
B
numbers to
is,
be co-prime?
yeah, so that means they don't have any common factors.
Okay.
If they have a common factor, we can cancel that out and then we are still left with like some sum. We still need that sum to still be small, basically.
Okay.
So we assume that there's nothing to cancel out. So the sum there, we want it to not give like a big fraction. So probably we can even just make it 1 directly. So in this case, you don't have to even think much about coprime, but that's like what can lead to this direction of thought. So
Okay.
if we just take B as 1 minus A, then this will just be A squared for example. So here we may not even necessarily need to fix A, so that we can actually, like, it'd be more complete to check the options. But if you want, you can still set your value for A, right? So this would be like 1 minus A all squared. This would be A into, after some adjustment. So you get these options, and then now the only issue would be to just compute U, V, W. So definitely we need another denominator, this guy, which would be this. Okay. So I'm just going to speed run this. Just press auto solve.
Autopilot. Guys, we're on
All right.
autopilot mode now.
Yeah, so we want this to be maybe small, but also we have to be careful. If we want this to be 0, so that we get 1, this might create some issues, because if we solve this, we need A to be either 1 or 0. That means one of B will have to be 0 or A will be 0. So we want to avoid that. That would be too nice. So maybe let's take A to be 2, for example. Right? So this sum will become 12 minus 6 plus 1. So at least this is not too bad.
So 7.
At least we don't need any more fractions beyond this. So this will be the highest denominator we'll work with. Then we can just continue like that. Should we finish along this track, or should I just...
Yeah. Let's finish along this track and see what happens.
Let's see. All right, so then let's rewrite A. Now, X is A squared, so that is 4. Y is 1 minus A, that's B squared, which is 1. Z is A into A minus 1, so that's 2 times 1, so this is 2. Okay, so now let's analyze the last options. So we need to get, we already have the sum, so we need to get U, which would be X squared over 7. So that's this minus 2. And quick solving will get to here, right? From 14. So here also, in a similar way, this will be 1 squared minus 4 times 2, which is 1 minus 8. So you get minus 1 here. And then, and based on what we solved, it's not surprising the answers we have, right?
Yeah.
So at this point, one may actually be able to even make a guess that maybe there's something bigger going on. So
Yeah,
we have 2 squared 4 times 1. So this is just 0.
Yeah.
So at this point, we can now go to the options, and clearly that option D will be a candidate, clearly. You just need to check a few. Probably most of them will not work out. Yeah, I don't think any of them work out. If you take the sum, this will be 7, but this will be 1, so the sum doesn't work. Yeah. So basically, this should solve it also, for instance. But you have to be careful with the values you pick.
Yeah.
Definitely don't want any two being equal.
I see.
But it's not advisable. Now, the final method I was talking about is just stressing observation, which is if you look at this, if we subtract A, right? If we subtract A, because like you could look at this as having this coming from this idea. You can picture it from this perspective. So if you subtract A, then it's supposed to give something symmetric. If we continue along here, maybe I should just continue from this path. So here we have A into, so we have like a symmetric part and then an almost symmetric part. So based on denominator, the first part is very simple. The second one is a bit more complicated. So this means if you subtract a minus x minus a, we get like a symmetric part. So this is important because it will be the same for.
So can you like just put a barrier to show that we're not saying that x minus a is equals to a minus this? I don't know if you.
Yeah, I get you.
Yeah.
So this is how we work generally, though. So you have to keep track with your solutions. Because this is more so like a rough where you're trying to like figure out some ideas. So it's not necessarily to be too strict with in terms of like the arrangement until you need to write a solution, right? Yeah. So for the sake of this, we'll just be more flexible. Exactly. All right. So basically, we just the point is to come to this conclusion either way. This is symmetric. So another way you can arrive here is just to take the difference between x and y. So what this gives, actually, let me conclude on this first. What this gives is this will also be the same as y minus b and the same as z minus c by symmetry.
By symmetry.
So symmetry is very, very powerful. So if we can maintain it in some way, it's usually handy. So this is what we get. Another way you can arrive at this same result is to consider x minus y. If you do this, you can expect for sure a minus b as a factor. The question is what follows after that. Based on symmetry, this is just without even knowing the expressions we're dealing with, we can be sure of this. Because if we make a equal to b, then x and y will have no difference in their expressions. So we expect 0. So this, by factor theorem, we can confidently say this is a factor. So usually you can start from this also to figure out maybe what's the other part, which should be something over a plus b plus c. And it turns out you just get that this is equal to 1. Should I go ahead and expand that maybe?
Yeah. Sure.
Okay. So let's consider it. CA. So same denominator. So now to get this factor out, you have to take the terms pairwise. Symmetry, like the symmetric sense. So a would go with a b squared, and this part we go. If you do it like this, factorization is usually a lot more straightforward. Each of them will have that factor actually of a minus b.
A minus b to a plus b.
Then here you have ca minus b, right? Yeah. So at this point we can get the result we desire. So this is a minus b. Then we have a plus b from the first part, and then we have plus c. So it's just a minus b.
So the question mark is 1.
Yeah. So this is precisely like there's nothing extra actually. It's precisely a minus b. So just from this alone, and the fact that u, v, w have like a similar relationship with x, y, z, the way x, y, z had with a, b, c, we can also say based on that symmetry that this would be x minus y. Just the same calculations. Just instead of a, b, c, we have x, y, z. So, and this is also a minus. So at least this, from some perspective, this can already give you some ideas. But either way,
so this is a really nice question. So from the point of view of now, so this I'm going way tangent. I'm going on a very tangent point here right now. So from the point of view of like linear algebra, right? Like when you have a system of equations and then you express it as a matrix, and then you talk of the rank of the matrix.
Right.
So so it goes to show you if you have like a set of vectors, whether they are linearly independent. So now we have 9 variables here. So let's say that if the 9 variables are all independent, then let's say that the rank of this system of 9 variables is 9. What can you say is the rank of these 9 variables? I don't know if that question makes sense to you, but I feel the people who are math enthusiasts will enjoy this question.
Well, to begin with, we know that A, B, and C, if we have their values, we can use that to determine X, Y, Z, right? And if once we have this also following the same, we get this. And no other equations are involved. These are all just like direct evaluations.
So we can say the rank
so
is 3.
we can say this is basically, yeah, it just depends on these 3.
Yeah.
Just that in terms of connecting with linear algebra directly would be difficult because now we don't have linear like expressions.
Yeah.
Per se. Yeah, it's almost in terms of degree, it's still linear overall, but we have some fractions, so that kind of throws some. Yeah, but there's a way maybe
so
we could.
I mean, I think the reason why this is interesting because we took 3 routes, right? So the second route was us substituting values. So I think the reason why this is interesting is because if you're going to take the route of substituting values, you don't want to start substituting more than 3 values.
Too many, exactly. Yeah. Actually, that was very important. So actually we did this subconsciously without actually throwing much light on it. So, but this is actually what happened, right? So you don't just randomly like say, okay, let U be 1. Maybe you now want to find like X. Yeah, that is going to be crazy. So yeah, I think it's just to go in the order it was presented. It's more natural. If you define more than that, then you probably have like some contradiction somewhere, or
so
you're just lucky.
There's some sort of like grouping going on. So I don't want us to discuss this because I don't want the video to be very long, but I feel maybe someone who is interested could actually explore maybe instead of fixing the values. So the second route we took, right, of solving this question, instead of fixing the values of a particular subgroup like ABC, how about you mix the groups? So you fix B, fix C, and fix X, and maybe explore. I mean, what happens? So you're kind of like breaking the symmetry. But yeah, it's just it's an interesting part to take.
Although from Olympia point of view, please don't break the symmetry. But if we were to break the symmetry,
I mean, you can do it outside the exam hall. I don't advise you doing it in the exam hall.
Yeah, definitely not in the exam hall. But it's good to explore because sometimes there may be things lying there just waiting to be discovered, right?
Yeah. Okay. So I think we've had enough discussion about this problem. So let's talk about how did the participants fare in this problem. So I don't know if you could display the distribution of how the options were selected.
Okay, I don't have it here. Do you have it in your, maybe you can.
Okay, if I can display it. Okay. Yeah, I would. So I'll have to share my screen, but let me
stop sharing. Okay, when you're ready. So just before we do that, just for those that are ready to explore, so consider this, and whatever you find, enjoy. Okay. Yeah. So suppose we have this kind of expressions instead. So this time now the degree is kind of reversed. Like you have the quadratic on the top, but now cubic under, so it's like reciprocal in some sense. So do this for like y, like b squared, but the same denominator, right? So just quickly. Now express UVW in the same way, and then check what happens with U. Probably have a guess, but let me leave that to. So that is like this. X cubed. Consider this. So what do you have for U? Yeah, so I'll just leave this for those that are curious-minded, basically. All right. So are you ready?
Almost there. Okay. I want to be able to display both the distribution and the problem. Okay, so I'll just open it now. Okay, yeah, I'm ready now.
Okay. Let me stop sharing then.
Okay. So
So this problem 21.
so let me yeah, so let's put it this way.
Great. Yeah, so the green color there, that's the right option as we just solved, D. And then here we can see the statistics of the options selected by the participants. And
Yeah.
there's like an obvious option here. An obvious correct answer that turned out to be
Yeah.
false, right?
Why do you think they would want to choose option C? Like why?
Yeah, so actually I think it's simple. Is symmetry, basically.
So
That's just it.
you
So
throw a lot of
like the
people.
rest are a bit too skewed, and that you need a bit more to make that like an intelligent guess
Yeah.
to stand out from the others. So, but C stand out in a special way. And then someone that feels like this could be like very complicated expressions would imagine that probably the others would not be so
Yeah, I see.
like, yeah. So you probably imagine it's some expression that when you add them, maybe they like some magic, it just comes together, right? So I think probably it's along this direction.
Yeah.
But the others are more similar to themselves. So if you think of any other one, then you have to consider the others as well.
Yeah, I see.
Yeah.
Yeah. Okay. So that'll be it for this video. And then see you in the next video. Okay. So I'll
Yeah.
stop. Yeah,
Thanks.
I'll stop recording now. Okay.